Identifying encryption issues. Data encryption is a technology whereby we start with what's called plain text or human-readable info. We apply one or more algorithms or functions or processes against that plain text and wind up at the end of this process with gobbledygook, basically, what's called cybertext, such that the data can be reconverted back to plain text if you own the data. Otherwise, the file is inaccessible. Now, there are different third-party solutions for doing file encryption or whole disk encryption. As you know, for the 7685 exam and for all Microsoft certification exams, we're concerned with first-party technologies. The first of those is encrypting file system, or EFS. This technology's been around for quite a while, as a matter of fact. Microsoft just tends to hone the technology with each successive version. Then we'll spend the rest of our time looking at whole disk, or actually more specifically whole volume encryption, using BitLocker and a feature brand new in Windows 7, BitLocker to Go. First, we'll have a look at encrypting file system, or EFS. EFS is a transparent file system encryption method. Transparent because a user can encrypt a file such that only that user can view it. Nobody else, regardless of NTFS permissions on that file or shared folder permissions, would be able to read it. You might know from your previous experience as desktop support technicians that as long as your volume is formatted with NTFS, NTFS unlocks a whole lot of additional technologies like NTFS file compression. EFS is certainly another one, and most particularly the ability to set access control list entries or security on a file-by-file basis. EFS supersedes even that. Therefore, it's a pretty strong and secure way to do business when users and groups want to protect data that's highly confidential for whatever reason. So again, transparent means that the user doesn't need to know anything about encryption protocols. They don't need to know anything about public key infrastructure, PKI, public keys, private keys. They just access the properties of the file that they want to encrypt, check a box, and they're done. Windows hides or abstracts all of the technical details from the user, which is really a good thing, but also I've seen or heard EFS referred to as a delayed or suspended recycle bin. That's a kind of a facetious or ironic way to describe EFS in terms of it's only going to be a matter of time before the user's user profile becomes corrupted. They lose their EFS key, and the data that they've encrypted is permanently rendered gobbledygook. Therefore, it's crucial as systems administrators in a domain environment to take care of data recovery, which we'll look at in just a second. First, though, you need to know some technical aspects of EFS. First of all, the editions of Windows 7 that support it. You'll notice that the consumer or home versions of Windows 7 do not support EFS. Microsoft gives us this technology on the Professional, Enterprise, and Ultimate editions only. If we look over on the right, this is an image I borrowed from wikipedia.org. They have a really nice article actually on encrypting file system that you might want to take a look at if you're interested in some of these more nerdy techno details that go beyond the scope of the certification exam. Now put your propeller hat on because I'm about to get pretty geeky on you. EFS in Windows is a hybrid encryption technology. Hybrid because it uses both symmetric key algorithms as well as asymmetric algorithms. Now what does that mean? When you're using symmetric key encryption, you're using the same encryption key, a key being defined as a very long number, to give you just the ground floor explanation. The same key both to encrypt as well as decrypt the file. If you're given a choice, dollars to donuts, in terms of symmetric key versus asymmetric key, symmetric key is always going to win out from a performance standpoint simply because we're using, again, the same key for both sides of that equation, for encryption and decryption. Now, while asymmetric is slower than symmetric key encryption, it's a lot more extensible. If you had two separate parties, two separate people who wanted to exchange data on each of their computers using symmetric key encryption, you would need to figure out a secure way to share that symmetric key with both parties. That presents obvious man-in-the-middle problems. In an asymmetric environment, you have two keys. A public key that is freely shared with other parties, and the public key is used only for encryption. And then there's a matching private key that the owner of this key pair needs to be absolutely vigilant about protecting, and the private key is used for decryption, as well as creating what are called digital signatures. Okay? Now, EFS uses both symmetric and asymmetric encryption in the following way. What happens is, the first time you go to encrypt a file in Windows Explorer, if you do not have an EFS digital certificate from, say, an Active Directory certificate services server, that's really what you want to do in business. If you don't have that, then the first time a file is encrypted on the machine, Windows 7 will generate a self-signed digital certificate and issue it to the user. Now that presents lots and lots of problems. Number one being, if the user encrypts files on several workstations, there are going to be several copies of a digital certificate, which makes management and recovery a nightmare. So once again, I can't stress enough, if you're thinking of deploying EFS in a domain environment, you absolutely should be using a public key infrastructure using Active Directory certificate services, and you deploy your key pairs that way. Now, the digital certificate is going to contain only the user's public key, and the user uses that public key, or should I say Windows 7 uses that public key to encrypt another key called a file encryption key, or FEC. Windows will create a FEC, or a file encryption key, each and every time a file is encrypted. And what happens is the user's public key encrypts the FEC, and then the encrypted FEC performs symmetric or much faster encryption on the plain text file, and then at the end of the process you wind up with a file that is protected, that's been encrypted with the file encryption key, the key that unlocks that file, so to speak. In other words, the FEC does decryption as well, is riding herd with the file in the file header. So when it comes to decrypting the file, the user is going to pop out their private key, which only they own now, and will be present as part of their user profile store. The private key that matches their public key can decrypt the FEC, and once the FEC is decrypted, we can move into that super fast symmetric key algorithm where the encrypted file becomes plain text. And all that happens behind the scenes. The user doesn't need to know anything about it. Now, some things to keep in mind again is that number one, the user's personal digital certificates, most pointedly their EFS digital certificate, is going to be stored in their user profile folder, which brings up the obvious implication: if something happens to that profile, whether it's deleted, corrupted, whatever, and we lose the EFS certificate, then that user will be unable to decrypt any of his or her EFS encrypted files. This brings up the crucial importance of the DRA, or Data Recovery Agent. DRAs exist both for EFS and BitLocker, which we'll discuss a little bit later on. Now, back in the olden days of Active Directory, Windows 2000, the default local administrator account was by default the data recovery agent for a local computer. That is not the case from Windows XP Professional up to Windows 7. That is to say, if you're not in a domain environment, local administrators do not have DRA privilege. Now, what that means actually, to be a DRA, is to have another digital certificate that gives you the EFS recovery privilege. And this is even more reason for you to be deploying your EFS certificates via group policy and using ADCS, Active Directory Certificate Services. In Windows Server 2003, 2008 domains, the domain administrator, not the domain admin's global group, but the domain administrator account, is a default DRA for the entire domain. So fortunately, if we're doing domain EFS, we do have that to fall back on. However, we can use group policy to specify entire groups or other users as DRAs that can perform that data recovery if something happens to a user's encryption certificate. Finally, I need you to be aware that EFS is managed, well, in a few places. It's enabled or disabled on a per-file basis in Windows Explorer. It's generally managed by systems administrators and domain administrators by using group policy. Or alternatively, we can use the cipher.exe command line tool to manage all aspects of EFS, including, as you'll see in the upcoming demo, using the R switch to create a recovery certificate. It is time for our first demo, so let's just jump right into Windows 7 and I'll show you how encrypting file system works in this latest and greatest version of Windows. We'll look at setup, configuration, and troubleshooting. In this demo, we take a look at Encrypting File System, or EFS, in Windows 7. To begin with, let's just set the stage for what we're doing. In my file system on WinNugget here, I've gone under C Tools. This is a folder I've created, and it's been kind of a catch-all bucket for files and applications we've used thus far in the course. I created a plain old text file using Notepad called Encrypted File, and it contains, as you see, confidential information. The first thing we want to verify here is that Windows Explorer is set to display encrypted files in an alternate color. Now, if memory serves, that color's green. I'm colorblind, as you know, so I'm never quite sure between red and green. What we can do is open the search box and type Folder Options to quickly get to that particular control panel option, and we'll navigate to the View menu, scroll down, and verify that the advanced setting called Show Encrypted or Compressed NTFS Files in Color is enabled, which it is there, so we're all set with that. Next, I just want to jump into Local Group Policy. As you see, I've created a custom Microsoft Management Console that contains two snap-ins. I've brought in the certificate snap-in, which we'll need in just a moment, and also the Local Computer Policy snap-in, because I wanted to show you that in terms of configuring data recovery agents, or DRAs, we need to do either local or preferably domain group policy to get this done. And as a review, remember that in a workgroup, there is no default DRA. Therefore, if user A on a Windows 7 box uses Encrypting File System to encrypt some data, and then user B, who happens to be, say, a local machine administrator, deletes user A's user profile or their account entirely, well, guess what goes along with that user profile? You guessed it, user A's Encrypting File System digital certificate. Without a DRA, nobody is going to be able to decrypt that encrypted data. You're in big trouble. Therefore, it's important in group policy, although the domain administrator account is the default DRA for an entire domain, you can specify additional identities by navigating under Computer Configuration, Windows Settings, Security Settings, Public Key Policies, and you'll notice now in Windows 7 we have DRA folders for both Encrypting File System, EFS, what we're doing now, as well as for BitLocker drive encryption, which we'll look at later in this demonstration. So we can right-click the Encrypting File System folder and select Add Data Recovery Agent. This kicks open a wizard from which we can simply browse either Active Directory, or if we're in a workgroup environment, you actually have to dig up the EFS Recovery Agent certificate from a designated user. So you notice you can't browse the local Security Accounts Manager database. You simply have to browse folders for the .sir file. Now, you already know, or you should know, that the cipher command is how we manage EFS from a command prompt environment. And in particular, there's a switch called R that enables you to generate an EFS recovery key and certificate and writes them to two files, a PFX file that contains the certificate and the private key, and the SIR file contains the certificate and the public key, you see? Therefore, let's hit up cipher R, and then we'll call it DRA. Asks us for password protection, and after confirmation, we have both of those files created successfully. You'll notice that we have a DRA SIR and a DRA.pfx. Now note that these are associated with the currently logged on user. I'm logged on as a local administrator named Trainer. If I want to be a recovery agent for all users on this system, remember this is local only, I'll browse to the C drive, find the SIR file, and it tells us first of all Windows can't determine the status of the certificate. This speaks to the fact that when we mess around with machine only or local certificates, you lose all, really, of the web of trust that digital certificates give. In the real world, we would browse Active Directory, and we would have an Active Directory certificate services store there. Alright, so it's giving us a clunky method. There we go. So now Trainer is a DRA, or data recovery agent, for this machine, and the file recovery is the purpose of this digital certificate, and the certification path is really not useful outside of the scope of this machine. Its certificate hasn't been given by a trusted root certification authority, as I said, like an ADCS machine in our domain. Alright, so much for that. How do we actually use Encrypting File System? Well, we can come to the file system, right-click a file, come down to Properties, come over to Advanced Attributes, and simply say Encrypt Contents to Secure Data. An exam alert always used to be Microsoft would want to make sure you understood that compress and encrypt are mutually exclusive advanced attributes. That is to say, you can compress but you cannot encrypt. You can encrypt but you cannot compress. So know that. Also note that you cannot encrypt folders. The only file system objects that can be encrypted with EFS are files. Now, if you mark a folder to be encrypted by right-clicking, properties, etc., the same thing, what will actually happen is that Windows 7 will send a flag to all contents in that folder and encrypt them. Now, you notice the encryption warning asks us, do we want to encrypt the file and its parent folder, which we now know is simply the contents of that folder, or what I'm going to do is encrypt only the file. We can click OK, we'll apply this change. We get a helpful pop-up that says we should back up our file encryption key to avoid permanently losing access. This is really nice advance in EFS technology in Windows 7. We can back it up now, we can be reminded later, or never back up. And basically that was just a front end, an Action Center based front end to the certificate export wizard, which we can get to elsewhere. I'll show you that in just a minute. In the meantime, you should see that encryptedfile.txt is displaying in an alternate color, and we can double click to open the file all day long with no problem. Now I'm going to log off as trainer and log on as the student account, and let's just take a look and see what happens there. We're now logged on as student, another user. I'm going to Windows R to bring up the run box. We'll navigate to our tools folder, and we see the encrypted file there. Let's take a look and see what information we can glean. It looks like we can access the metadata of the file, but if we attempt to open it, although the associated application handler, Notepad, opens, we get an access is denied error when we attempt to actually open the file. And that's as it should be, of course. We'll now log on as trainer. We're still getting pestered by this Action Center pop-up to back up our file encryption key, but I'm going to go one step further by opening up Run and typing certmgr.msc. This is a shortcut to open the certificate store for the currently logged on user. Now, this is nice if we want to see the user's certificate store. If we wanted to see the whole computer's certificate store, that is to say the digital certificates that affect all users on the system, we can open up a blank MMC console, do our add remove snap-in dance, and when we select certificates, check this out. We can focus the certificate store on my user account, the service account, in other words the operating system, or the computer. It's nice to have that flexibility here in Windows 7. But what we're interested right now is this, and by all that's right, I should have gone in here before I encrypted a file, just to prove to you that in the personal digital certificate store, there was nothing here. When you're using just local computer EFS certificates, which again, to repeat ad nauseum, you don't want to do this in business. You want your users to receive their EFS certificates from an Active Directory certificate services machine. That's how you can distribute those EFS certificates and centrally manage them. But the way it works on the local machine is that the user has no EFS certificate the instant that he or she encrypts a file, like we did by navigating to the tools folder and looking at the properties of encryptedfile.txt. Then the operating system creates this EFS digital certificate, gives it to the current user. And yet again, we don't have a certification path, but other than that, it contains the public key, just as we learned about earlier in the course. Alright, fine. Now we can also manually back this guy up by right-clicking and selecting Export from the shortcut menu. This is another way to do the certificate export process. I'm going to choose yes. I'm going to actually export both the public key and the private key. I'll use the default PFX format, supply a password. File name, let's just put it in our tools folder again. I'll call this backup and finish. Now this is going to come to the fore if something happens to that certificate, like it's been deleted. Remember, if something happens to the user's profile, unless you're storing the certificate in Active Directory, you're very vulnerable in that regard. So now if I try to open encrypted file, I guess now, until I restart, I'll be okay. But once I restart, I'm not going to be able to open this file up anymore. Bottom line with that is, as long as we have a valid backup of the EFS key, and by the way, all of these certificate backup routines and restoration routines function the same way for BitLocker. We can say or click import from the shortcut menu. This just does the opposite, certificate import. We can browse to where the file exists. I think we put it in tools. Yeah, in tools. And you notice that by default we're looking for just the public key, the SIR file. In order to see what we backed up, we actually backed up all of our keys, so we have to change the filter to Personal Information Exchange format. Select our PFX file, of course, add our password in, choose a different store. I'm just going to leave it in the default one, and then we have our certificate back. Easy peasy. Final thing, to revoke or remove encryption, we just can revisit properties, revisit advanced, untick encrypt contents to secure data, and you're back in business. BitLocker. BitLocker caused quite a kerfluffle, and I mean that in a mostly positive way, when Windows Vista was introduced by Microsoft, because we finally had a first-party solution for doing full volume encryption. Sometimes we refer to BitLocker as a full disk or whole disk encryption, but it's not exactly like that. Instead, BitLocker works on a volume by volume basis. And in case you're shady on what a volume is a formatted partition. A single physical hard drive can have just a single volume, and when we format a partition and create a volume, we get a drive letter, and we also get a file system, don't we, such as NTFS. Or alternatively, we can have more than one volume on a single machine. Now, some enterprises have actually gone to BitLocker after seeing how it's improved in Windows 7 and Windows Server 2008 R2. There are third-party solutions. There's quite a market, as a matter of fact, for full volume or whole disk encryption. SafeBoot is a good example there. Of course, the big deals or benefits of BitLocker, as opposed to a file system encryption method like EFS, is that we can protect our confidential data against theft. That's the chief thing that BitLocker addresses, and I'll give you a good example of that. Let's say our corporate folks have company-issued laptops, and that laptop is stolen, disassembled by the thief, and the person takes the hard drive out, moves it into another chassis, maybe some kind of drive enclosure, and tries to access the data off that drive in the hopes of garnering confidential information. Well, if we've protected that drive with BitLocker, then bottom line is the user, the malicious user in this case, would not be able to access the drive at all. Certainly wouldn't be able to boot an OS off of it, but even if we attached the drive as an external, say, USB device, there's no go. There's no data access at all. Even if the thief tried to boot the computer with the hard drive in its original slot, unless you had, for instance, a USB key attached, also called a dongle, and or unless you knew the PIN, you're not going to be able to boot that computer. So that's the idea with BitLocker. EFS is cool for protecting individual files, but a third-party product like SafeBoot or a first-party product like BitLocker gives us protection against someone even physically removing the drive and trying to access its contents elsewhere in what's called an offline attack. Now, just for completeness, I told you about SafeBoot. There are certainly really nice third-party products that do file system encryption. You're not going to see this on your exam, of course, but TrueCrypt is an absolutely wonderful tool, and you can't beat the price. It's free for doing file system level encryption. Anyway, back to BitLocker. Some more technical specs that you need to be aware of for your exam. Notice that we have even stricter edition requirements with BitLocker than we did with EFS. That is to say, BitLocker is supported only on the Enterprise and Ultimate editions of Windows 7. Just be that as it may. Now, before we talk about BitLocker to go, I want to spend a moment discussing how BitLocker has changed for the better since its original iteration in Windows Vista. First of all, when BitLocker was first released in Windows Vista, you could only encrypt the system volume. The system volume is almost always drive C, and it's the volume that boots the computer. Now in Windows 7, you can encrypt any volume. So if you had an OS volume and a data volume, you could encrypt the data volume. Nonetheless, though, regardless of which volume you choose to encrypt, you have to access a special hidden partition that fortunately is created for us as part of Windows setup. You're going to see this in the upcoming demo. I'll show it to you. And this makes preparation for BitLocker pretty much automatic, or automagic, as some old friends of mine used to say. You might remember, if you've tried to use BitLocker under Windows Vista, that you either had to use a third-party partitioning tool, like, say, Partition Magic, or you had to hit Shift F10 during Windows Vista setup to manually create an additional partition in order to host BitLocker. And the reason for this is, if If we were to, say, encrypt drive C, how could we boot the operating system? How can the BIOS, when it looks for a master boot record and looks for a partition boot sector and looks for WinLoad and the other core boot files, it's not going to be able to access those. Therefore, it stands to reason that BitLocker needs the core boot files moved to another partition, and it will use that partition for bootstrapping. So to go back in time to Windows 7, what many administrators had to do was to download a free program from Microsoft called the BitLocker Drive Preparation Tool. And what that would do is, in a graphical environment, shrink up your C drive enough such that it gave you a 1.5 gig S drive, basically. And that was another weakness, actually, of this Vista BitLocker, is that the drive that BitLocker needed to boot, that needed to be unencrypted, actually showed up in Windows Explorer. You're going to see in the upcoming demo that under Windows 7, that BitLocker boot volume is hidden, has no drive letter. User wouldn't even know it's there unless they opened up the disk management console. And that is where your core boot files are held. Now, BitLocker to go, we're not going to spend an awful lot of time on this because, frankly, the BitLocker proper is much more compelling and is more likely to be seen on the exam. BitLocker to go is an extension of BitLocker that provides the ability to encrypt removable device volumes. For instance, if you have a MyBook, one of those big ol' Western Digital plug-in USB drives, you can encrypt one or more of those volumes. You have more flexibility in being able to unlock a BitLocker to go drive. You could use, for instance, a passphrase, which does make the BitLocker to go drive a little bit portable. That is to say, if you were ping-ponging in between two Windows 7 Ultimate Edition machines, as long as you had the passphrase, you could access that BitLocker to go encrypted volume. As I mentioned earlier in this nugget, there's the concept of the data recovery agent, or DRA. We can specify a DRA for BitLocker just like we can with EFS, and as you know, that's done through group policy. Although this is the last bullet point on this whiteboard, and I've written it kind of small, TPM is really the anchor point on which the entire BitLocker technology is hinged. The Trusted Platform Module is a specification for crypto processing and the storage of cryptographic keys, but it's also the implementation of that specification. In other words, a TPM module is a physical chip that's soldered into your motherboard. Thus, to take full advantage of BitLocker, your laptop or desktop computers have to have this already on the motherboard. And what's a little bit frustrating, frankly, is you get to TPM settings in System BIOS, but depending upon the BIOS manufacturer or the original equipment manufacturer, sometimes it's not called TPM. It's called something like security device or integrated security. So you have to be careful and read your motherboard documentation to find out what's what. But basically, TPM presents a hardware mechanism for storing cryptographic keys, and you'll see how that works in the next whiteboard. BitLocker modes. What you see here is at first what looks like an overwhelming list of options, but really it's not so bad. You do have to understand these modes before you sit for your 685 exam, so certainly listen up. The first mode that we're going to discuss is the TPM only mode. This is also called the transparent mode. And what this is it's really easy on the user. As long as their computer has a Trusted Platform module installed on the motherboard and that you as an administrator have configured BitLocker to use this transparent mode, as long as the hard drive, the boot drive, is where it should be in terms of drive interface, plug into the motherboard, etc., the system will boot just fine. But if the hard drive is stolen and removed from the box and put into another machine or just a USB drive chassis, then the hard drive is going to be inaccessible. So the trade-off is, on one hand, TPM only mode is really convenient. The user doesn't even need to know that it's there. They're not stopped to enter a key or a pin or anything like that. But on the other hand, if someone were to steal the entire computer, leave the hard drive in there, they would have a crack at logging on to the operating system once the boot up completed, you see? Now, we're getting into gradually more secure, but also more difficult to manage options for BitLocker. We can also do TPM with a startup key. The way this works is you have a USB thumb drive that has the startup key, which is just a plain text file. It's tiny. It takes up just about no space, stored on that flash drive. And you not only need to have the hard drive in its original socket in the computer, the original interface, the whole deal. But you also have to have your USB flash drive or a USB flash drive plugged in that has the appropriate BitLocker startup key file on it. Cool thing about this is, as long as the user is being careful in separating storage of the computer and the startup key, even if someone were to steal the entire computer, they wouldn't be able to boot it because they don't have the startup key. If you don't want to rely upon this mechanical, although it's actually solid state device, you can go for TPM with PIN. This provides the security against any movement of hardware in the chassis and also requires the user to know something. That is to say, they have to enter their personal identification number or PIN. To get even more jiggy with it, the most secure option is to use the TPM chip, have the startup key plugged in, and the user has to put in their PIN. So yet again, we're faced with that trade-off between higher security on one side and user convenience on the other. Now, the big question that so many folks have is, although my computer is fairly new, it's not new enough, or I just don't have the option for onboard TPM. Am I left out in the rain when it comes to BitLocker? Unfortunately, the answer to that is no. You can in fact use BitLocker provided that your Windows 7 edition supports the technology without TPM by going into Group Policy and setting a specific policy option. I'm going to show that to you in the upcoming demo, as a matter of fact. So that's pretty much it. You decide on a mode for BitLocker. If you have TPM, if you don't have TPM, a prereq is to do your group policy configuration. And then it's just a case of starting up the BitLocker wizard and answering some simple questions, and you're good to go. Now, on the other side of things, recovery, if something goes bad, for instance, if you're using TPM with startup key and you lose your thumb drive, or if you're doing TPM with PIN and the user forgets his or her PIN, now we need some backdoor method of starting the operating system, don't we? There you've got two ways to go. The password, the recovery key, those are really long strings of numbers. As long as you have that recovery information, the recovery password and or the recovery key stored offline somewhere, you can either type the recovery password directly via the keyboard, or if you have the recovery key for that computer, you can put the file on a USB stick, pop it into the computer, and let the machine read the key off the USB stick. So there is a way to do this. And I also want to give you a heads up that Microsoft has made it easier for enterprises to handle recovery in terms of what's called Active Directory escrow. Escrow, of course, means storing some material off to the side somewhere. Well, in this case, we're storing one or both of these objects in Active Directory for easy retrieval if we need them. In this demonstration, we take a look at BitLocker drive encryption. I'm on a Windows 7 Ultimate Edition PC named Win7 Nugget. And to get started, I'm going to open up a custom Microsoft Management Console that I created that contains two snap-ins. I brought in the Disk Management snap-in as well as the local group policy snap-in. To begin with, this is especially useful for those of you who have experience configuring BitLocker in, say, Windows Vista. I wanted to show you the disk configuration of my machine just to demonstrate what we talked about earlier in the whiteboard portion, where I said that now under Windows 7, most or all of your BitLocker system configuration is enabled right out of the box. You'll note here we have a system reserved partition that I got by default. Windows 7 setup did not ask me about this, it just went ahead and created it, whereas under Windows Vista, your system volume had to be fairly large, 1.5 GB. You'll note that here we just need your core boot files, so the system reserved partition that this machine will wind up booting from is a 100 megabyte NTFS volume. And again, in comparison to what it used to be in Windows Vista, there's no drive letter attached to this drive. Therefore, it does not show up in Windows Explorer at all. That's a nice advantage instead of seeing this S drive. That's bound to cause support calls from your customers. All right, the next thing I want to do is show you where in Group Policy we configure Trusted Platform Module, or TPM. In Windows 7 GP, it's under Computer Configuration, Administrative Templates, Windows Components, BitLocker Drive Encryption. And you'll notice that the BitLocker Drive Encryption folder has several policies at the ground level as well as 3 subfolders. Now, if your system does not have a TPM chip, like my system does not, we have to go into Operating System Drives and open the policy Require Additional Authentication at Startup. And we need to enable this policy, which you see I've already done, and I have to check the option Allow BitLocker without a compatible TPM. That's unchecked, and this is not configured by default. So this is stuff I've already done in the background. If your system does have a TPM chip, you can require the TPM and then set up startup pin and or startup key options down below. We've already learned about these. Pin only, key and pin for maximum security. But because my system does not have TPM, I'm enabling that policy, and of course I also need to open up an elevated command prompt and run GP update force in order to ensure that this machine receives those policy settings. All that having been done, we can now proceed to enable BitLocker or BitLocker to go, depending upon whether we're encrypting a volume, that is to say a fixed disk volume, or a removable device volume. I'll open up Computer on this system, and I'm going to enable BitLocker for the system drive, my C drive. Now, if I did have a USB removable disk, to do BitLocker to go is the same exact thing. We just right-click and select Turn on BitLocker from the shortcut menu. Those of you who are new to BitLocker in Windows 7, this is just going to seem fairly intuitive and straightforward. To repeat yet again, those IT professionals who have struggled with BitLocker in Windows Vista will notice a lot of really cool advances in this technology now that we're in Windows 7. In particular, the fact that the BitLocker drive preparation tool is rolled into Windows 7. We could say that it's baked in to the appropriate Windows 7 editions. Now you notice that prior to seeing this Set BitLocker Startup Preferences screen, you might have noticed that the interface said Checking System Requirements. So in the background what was happening is that the BitLocker Drive Encryption Wizard was looking for the presence of that startup volume, which I just showed you exists already, and whether we have appropriate group policy settings. Because we've passed those checks and we've enabled non-TPM BitLocker, we see Set BitLocker Startup Preferences tells us this computer does not appear to have a TPM. To use BitLocker, a startup key on a USB flash drive will be required every time you start the computer. That's the price we have to pay for this. Therefore, you'll notice use BitLocker without additional keys. That's the transparent mode supported by TPM. That's unavailable, as is the personal identification number or PIN option. Literally, all we can do now is require a startup key at every setup. In the Save Your Startup Key section, we'll select the USB thumb drive that I have installed on this computer. It's showing up as drive E with a volume label of Pearson. We'll click Save. And next we're asked where we want to store our recovery key. Although we discussed recovery keys in the whiteboard portion here, to make sure we're covering the exam objective and because this is such an important topic, let's take a look at this. A recovery key, the dialog says, is different from your PIN or startup key. It's used to access your files and folders if a problem with your computer prevents you from doing so. In this case particularly, where we do not have TPM, if our USB thumb drive were to become lost, stolen, or otherwise corrupted, the recovery key is going to be the only way we have to recover the system. That is, unless we're also doing key escrow in Active Directory, which I'll show you in just a moment. You also, best practice, want to store your recovery key separately from your USB flash drive if you're using your startup key on that drive. I'm going to save the recovery key to a file, and I'll just navigate to the local file system, my tools folder, and you notice it gets saved as BitLocker recovery key and then the key value.txt. Well, that makes sense that we can't save the data to an encrypted drive, so we're going to have to choose somewhere else. Why don't I just store it on the flash drive then? Click Next. And then, are you ready to encrypt this drive? Tells us that we can keep working while the drive's being encrypted. The performance of the computer, of course, will be affected, as well as free space is going to be dramatically reduced. I found in my experience with BitLocker that as it's encrypting your volume, it makes use liberally, to say the least, of the remaining free space on the drive as it's swapping data in and out of an encrypted state. By default, the Run BitLocker system check is enabled, and this just makes sure it does a read-write operation to make sure that it can read the recovery and encryption keys. I'm going to cancel out of this right now. We won't do this process because the bottom line is it encrypts drive C, and then henceforth forth, then as long as I have the recovery key on the USB stick and it's in place in a port on the computer will start normally. If I boot without the thumb drive, I'm going to only be able to boot the system if I have that recovery key information. And here you see the contents of that recovery key file that I saved. It gives us the recovery key ID, full recovery key ID, and then the BitLocker recovery key. For completeness, as I said, I want to show you where we specify Active Directory recovery key escrow. Again, I've opened up the local group policy editor on this machine and navigated to computer configuration, administrative templates, Windows components, BitLocker drive encryption, and at the root level of that folder you'll see a policy called, let me stretch this out, Store BitLocker recovery information in Active Directory domain services. So let me pop open this policy, and we can optionally require BitLocker backup to Active Directory domain services. And as far as the recovery information to store, we can store the recovery password as well as the key packages, the encryption decryption key packages, or just the password. There you have it. Identifying encryption issues review. In this nugget, we looked at the two chief ways that Microsoft supports data encryption. Of course, our focus of consideration is Windows 7. We looked at encrypting file system, which you'll recall is a file system, file-level encryption technology. We also covered pretty thoroughly, I think, both BitLocker with a special nod to its portable version, BitLocker To Go. I hope that you have a much better idea of how this technology works in terms of the specific requirements as well as its practical application than you did prior to viewing this nugget. I hope that this has been informative for you, and I'd like to thank you for viewing. Oh, American dream.